Welcome all of you dear students. This is the simplest and easiest way of teaching learning process in our most favorite YouTube channel Physics Make It Simple by Dr. Rajendra, serving as a principal in Lokanete Dr. Balasaheb Vikhe Patil, Padma Bhushan awardee, Pravara Rural Education Society's Mahatma Phule Vidyalaya and Junior College, Dad Budruk Taluka, Rahata District, Ahmednagar. As long as wave optics is concerned, this is the lecture number 12 of 12 Science, and in this lecture we wanted to discuss very funny phenomenon of light, that is interference of light. Many of the students are puzzling regarding the concept of interference of light. What is interference of light actually? To understand this concept very well, my humble request to all of you dear students, listen this lecture very carefully up to the end of this video so that you can get clear cut idea regarding interference of light. Okay. So before starting directly the interference of light, we should know principle of superposition of waves. So what is principle of superposition of waves? Because interference of light is based on the phenomenon of principle of superposition of waves. Well, see here, I have taken a certain point here, and one thing is, remember that for the principle of superposition of waves, we require at least two light waves. For the principle of superposition of waves, we require at least two waves. Two or more than two waves, okay, but two waves are must for the principle of superposition of waves. So see this diagram. So this is one wave having displacement x1 from this point. This is another wave having displacement x2 from this point, and these two light waves meet at a single point. So when two light waves arriving at a point simultaneously, then each wave produces its own displacement. This wave also produces its own displacement, and this wave also produces its own displacement at that point. Okay. Suppose the displacement of this wave traveling a distance x1 up to this point is 5 centimeter upward at this point, and displacement of this wave covering a distance x2 at this point is 3 centimeter downward. One wave producing displacement 5 centimeter upward at that point, and this wave produces displacement 3 centimeter downward at that point. Listen carefully. One displacement is upward, which is 5 centimeter, and another displacement is downward, which is 3 centimeter. So what is the resultant displacement? To get a resultant displacement, there is a subtraction of two displacement, because one displacement is upward 5 centimeter and another displacement is downward 3 centimeter. So 5 minus 3, we get 2 centimeter displacement, which is in the upward direction. Okay. Suppose this wave produces 2 centimeter displacement upward, and this wave also produces 2 centimeter displacement upward. Then two displacements are on the same direction, which is upward. So 2 plus 2 will get 4 centimeter at that point. Suppose this wave produces displacement 2 centimeter upward, and this wave produces displacement 2 centimeter downward. Then 2 and 2 both are opposite in direction. So resultant displacement is 0 because there is a subtraction. And so that to make a definition of principle of superposition of two waves means it is a combination of at least two waves. It is a superposition of two waves. It is a mixture of two waves. When two waves are superimposing with each other at a particular certain point, then what is the resultant displacement at that point? So, definition of producing the principle of superposition of waves is like this. When two waves arrive at a point simultaneously, each wave produces its own displacement. Each wave produces its own displacement. This wave also produces its own displacement. This wave also produces its own displacement. So, resultant displacement is the vector sum, SUM, vector sum of the displacements of two waves, that I have already explained. Sometimes two displacement add with each other, sometimes two displacements subtract with each other. That is called as vector sum, because the displacement is a vector quantity. It has not only magnitude but direction. So, repeat that definition. I will repeat that definition again. When two or more than two light waves arrive at a point simultaneously at the same time, simultaneously means at a same time, then each wave produces its own displacement, no doubt. Each wave produces its own displacement at that point. Then resultant displacement is the vector sum of the displacements of two waves at that point. Is it clear? And that is nothing but principle of superposition of light waves, dear student. And interference of light is what actually? Interference of light is nothing but the mixture of light, mixing of light, by making use of principle of superposition of two waves. Then how the definition of interference of light is to be prepared? The process of enhancement or cancellation of the displacements at that point due to principle of superposition of waves, so that we get alternate bright and dark point, we call it as interference. No, you haven't understand. Okay, you have well understand, I think, what is principle of superposition of waves. So, interference is a phenomenon, is nothing but the process of enhancement, means two displacement add together and there is an increase in the displacement of the particle at a particular point. Or the process of cancellation, two displacements cancelled with each other, one displacement is upward, another displacement is downward, then there is a cancellation. So, this alternate enhancement and cancellation, if the displacement is increased, then we get bright point. If the displacement at that point is decreased, we get dark point. So, the process of producing alternate bright point and dark point due to principle of superposition of waves, we call it as interference. This is interference. That phenomenon is called as interference, and this interference is produced due to principle of superposition of waves. So, how we can write the definition as long as examination point of view? The process of enhancement or cancellation of the displacement at a particular point due to principle of superposition of waves, so that alternate bright point and dark point is formed on the screen, we call it as interference. This is the simplest definition, dear students, that you can able to write and you can easily understand as long as your examination point of view. Okay. So, we have learned two definitions, two concepts very clearly: principle of superposition of waves and how the interference phenomenon exists by making use of principle of superposition of waves. Okay, then we will proceed further. So we have to derive the relation between phase difference and path difference. So this is the path followed by this wave. So distance travelled by this wave is x1 and distance travelled by this wave is x2. x2 path is greater than x1 path to reach these two waves at a particular single point, so that two waves mixed with each other. So this path is greater. So what is path difference? Path difference is x2 minus x1, because x2 path is greater, and so the path difference is not x1 minus x2. No, path difference is x2 minus x1. What are the two equations of light that I have written on the board? y1 is equal to a1 sine omega t plus kx1, equation of this wave. What is the equation of this wave? y2 is equal to a2 sine omega t plus kx2, where a1 and a2 are the amplitudes of two waves and omega remain constant in both the waves. Omega is nothing but the angular frequency. Frequency must constant to get well and sharp defined interference pattern. This is most important thing. Frequency of the waves should be same to get steady interference pattern. These are the two equations of waves. So this is a phase, that is the angle of this wave. This is a phase or angle of this wave, having equation y2 is equal to a2 sine omega t plus kx2, y1 is equal to a1 sine omega t plus kx1. These are the phases. So phase difference is nothing but the subtraction of two waves. So which phase is greater? This phase is greater because it travels larger distance x2. So I have taken this phase at first. Phase difference I have denoted it is by phi. So I can write here omega t plus kx2 minus omega t plus kx1, and after solving this what we get? Omega t plus kx2 minus omega t minus plus minus kx1. Omega t get cancelled and we get phase difference phi is equal to k into bracket x2 minus x1. This x2 minus x1 is nothing but path difference that I have already told you. So we have to derive the relation between phase difference and path difference, because it is very much important for every computative examination point of view. So here I will write phi is equal to k delta x. This is k delta x. x2 minus x1 is delta x. What is the value of k? Remember well, the value of k is 2 pi upon lambda, that I have put there, and so that we get what? Phi is equal to 2 pi upon lambda into delta x. So phi is nothing but the phase difference is equal to phi is equal to 2 pi upon lambda into path difference. So this is the relation between phase difference and path difference. Don't make mistake while remembering the formula of remembering the relation between phase difference and path difference. Phase difference is equal to 2 pi upon lambda into path difference. How we can remember this? 2 pi is there. Path difference, pi is there. Pi, path difference. So phase difference is on LHS. Phase difference is on LHS. Pa. This term comes on right side. Pa. 2 pi upon lambda into path difference. Pa. Come to on one side. So phase difference is equal to 2 pi upon lambda into path difference. Pi, path difference. And 2 upon lambda is constant. So don't make mistake. Many students may make mistake like this. path difference is equal to 2 pi upon lambda into phase difference. No, wrong. How we can remember it? That I want to discuss with you. Phase difference is equal to 2 pi upon lambda into path difference. That's all. Very interesting, very important formula as long as many computative examination point of view. Phase difference phi is equal to 2 pi upon lambda into path difference. That's all. Then we have to learn what is the resultant amplitude. See here. This is a amplitude A1 of first wave. This is the amplitude A2 of second wave, and phase difference between two waves is phi. So this is one wave, this is another wave having amplitude A1. This is amplitude A2, and we get resultant amplitude AR. So complete a parallelogram like this, and this red arrow suggests resultant amplitude AR. So as long as vector analysis is concerned, that you have learned in 11th standard, how we can calculate this AR. We get formula AR square is equal to A1 square plus A2 square plus 2A1 A2 cos phi. Such a type of equation you have already learned in 11th standard while learning scalars and vectors. So by making square root on both sides, you will get AR is equal to square root of A1 square plus A2 square plus 2A1 A2 cos phi. This is equation A. This is a formula of resultant amplitude of resultant displacement, resultant amplitude of resultant wave. Then we know another one important statement: intensity of each wave is directly proportional to square of the amplitude. I is directly proportional to A square, or we can write I is equal to Ka square. I is equal to Ka square, where this K is proportionality constant. See here, by making use of first equation, what is A square? A square is equal to I upon K. I will write here. A square is equal to, see here, A square is equal to I upon K. Making use of this equation, what is AR square? So AR square is equal to IR upon K. What is A1 square? A1 square is equal to I1 upon K. What is A2 square? A2 square is equal to I2 upon K. What is simply A1? Root of I1 upon K. What is simply A2? Root of I2 upon K. A root of complete root of I2 upon K, or we can write like this: root of I upon K, like this. This may be written as root I upon root K. This is A. A is equal to root of I upon K. This may be written as root I upon root K separately. So putting that value in equation 1, we get what? AR square is equal to IR upon K is equal to A1 square is equal to I1 upon K plus A2 square is equal to I2 upon K plus 2 as it is. What is the value of A1? Root I1 upon root K. What is the value of A2? Root I2 upon root K into cos phi. So this K and this root K and root K becomes K. This get cancelled, and you will get what? IR is equal to, what we get? IR is equal to I1 plus I2 plus 2 root of I1 I2 cos phi. This is the resultant intensity. This is the resultant intensity. This formula also you should remember. Resultant intensity IR is equal to I1 plus I2 plus 2 root of I1 I2 into cos phi. Then direction of resultant displacement, that is resultant displacement YR, is given by this formula. Also you have learned in 11th standard, that is tan theta. Direction is denoted by tan theta. Theta is the angle between resultant amplitude and amplitude of one wave, that is A1. So tan theta is equal to A2 sin phi upon A1 plus A2 cos phi. So these are some important formulae regarding interference of light. We should know it while learning in CET NEET JEE examination point of view, that all equations you should follow to solve many MCQs and numericals. So this is the fundamental concept of interference of light that we have learned today. Then in the next lecture we will proceed this interference in more detail by taking another new article. So goodbye. We will stop here. Subscribe my channel, and whatever you haven't understood, again repeat the video, listen it carefully, and take a short note to write in your notebook. Okay.